Hey everybody, welcome to today's lesson on hemodynamics, the study of blood moving through the circulatory system. This lesson focuses on blood flow patterns and flow volume, with discussions about how changes in vessel radius affect resistance and flow, as well as the clinical implications of altered flow patterns. In hemodynamics, we need to be able to answer the questions, how much blood is flowing, and how fast is the blood flowing in the circulatory system. This is because how much and how fast blood is flowing tells us how well the circulatory system is functioning. Flow, also called volume flow rate or flow volume, answers the question about how much. When we discuss flow, we're discussing the volume of blood moving during a particular time period, and we measure it in volume divided by time, like milliliters per minute. Velocity answers the question about how fast. When we discuss velocity, we're discussing the speed of blood moving from one location to another, and we measure it in distance divided by time, such as centimeters per second. We can use velocity to discuss different forms of flow: pulsatile, phasic, and steady. Pulsatile and phasic flow occur when blood moves with variable velocities. Pulsatile flow occurs as the result of cardiac contractions and appears in arterial circulation, while phasic flow occurs as the result of respiration and appears in venous circulation. Steady flow occurs when blood moves at a constant velocity, similar to water coming out of a garden hose, and occurs in venous circulation when individuals stop breathing for brief periods of time. Not only does blood flow at different velocities throughout the body, but blood may also flow in different patterns dependent upon vessel structures. The different patterns of blood flow are laminar or turbulent. Think of a river. Water in a river almost flows in layers. The water along the banks of the river is flowing more slowly than the center because of the friction the water encounters as it flows against the bank. When there's something in the river that disturbs the flow, like a widening or logs or rocks that narrow the river, it causes the water to become more turbulent and creates flow opposite to the main stream. Laminar flow occurs when blood moves in smooth, parallel layers. Laminar flow is characterized by either a parabolic velocity profile or what is called a plug profile. In parabolic laminar flow, the layer closest to the vessel wall moves more slowly due to friction, while the central layers flow faster. In plug laminar flow, all of the layers and blood cells travel at the same velocity. Plug flow occurs in larger arteries, while parabolic flow is seen in smaller arteries, where frictional forces between the flow layers and the vessel wall have a greater effect on flow layer velocities. It is important to understand that laminar flow occurs when vessels are normal and healthy, and laminar flow is silent. The smooth, regular movement of the blood causes minimal disturbances in the flow, which results in a lack of sound production, so it would not be heard by a stethoscope. Turbulent flow typically occurs when the blood velocity increases to the point that the layers no longer flow in parallel, but instead become disordered, flowing at different speeds and in different directions. This results in eddies or swirls of blood flow, which can be perceived as sound. Turbulent flow generates a sound called a bruit that can be heard by a stethoscope. Turbulent flow also causes vibrations that can be felt upon examination, called a thrill. Turbulence is commonly seen in conditions such as vascular stenosis, which is a narrowing of the vessel lumen. It can also occur with high-velocity blood flow. Differentiating between laminar and turbulent flow helps to diagnose vascular abnormalities, assess blood flow patterns, and identify potential sources of pathological conditions like stenosis or aneurysms. In summary, in hemodynamics, flow, also called volume flow rate or flow volume, tells us how much blood is flowing, and velocity tells us how fast. We can use velocity to discuss different forms of flow: pulsatile, phasic, and steady. Pulsatile and phasic flow occur when blood moves with variable velocities. Steady flow occurs when blood moves at a constant velocity. Blood may also flow in different patterns, either laminar or turbulent, dependent upon vessel structures. Laminar flow occurs when blood moves in smooth, parallel layers. Turbulent flow occurs when the blood velocity increases to the point that the layers no longer flow in parallel, but instead become disordered.